Welcome to qnawire.
So over here we want to identify in magnetite what is going to be the ratio of iron 2 plus to iron 3 plus that we're going to have in iron 3O4. So in order to do this, let's remember that the oxygen is going to contribute each of them to -2. So -2 times 4 is going to give us -8. So that means that the ratio that we're looking at is iron times X plus 2, iron Y times 3 plus, times oxygen 4, which is going to account to -8, and we want the values to be equal to 0. So in this case, the values that are going to satisfy this condition are going to be of X, we're going to have 1, we're going to have 1 of the iron 2 plus, and we're going to have 2 of the iron 3 plus, and O4, which accounts to -8. Notice that this is going to give us a total of 0 charge. So the ratio of iron 2 plus to iron 3 plus is going to be equal on 1 to 2. Next up, we want to know what is going to be the type of spectroscopy that could be used to determine the relative abundances. So in this case, there are going to be several techniques that we're going to employ, and the most common one for quantitative analysis of the relative abundances of these ions is going to be Moss-Bauer spectroscopy. And finally, for part C, we're going to be given two different isotopes. In this case, it's going to be iron 54 over here. Charging for some reason. Okay, we're going to have iron 54 with 26, so the number of protons, neutrons, and electrons that we're going to have in this case is going to be 26 electrons, and on the middle we're going to have 28 neutrons. And on the other hand, for iron 56 with a charge of 3 plus, the number of protons is going to still be 26, the neutrons are going to be 30, and the number of electrons should be 23 electrons. And that would be all. Thank you very much, and have a good one.